In this video, we will discuss Euler's method of solving differential equation. For this, we will consider the differential equation dy by dx equals f of x comma y and let y equals phi x be its solution. We will draw the solution curve PQ. P and Q are two neighboring points very close to each other, where P is xn, yn and q is xn plus 1, yn plus 1. P and q are very close to each other such that horizontal distance between them, which is xn plus 1, that is OM, minus xn, which is ON, is very small, and we will denote it by h. We will draw a tangent at point P which cuts vertical segment QM at T. As the neighboring points P and Q are very close to each other, tangent PT can be considered to be same as the functional curve PQ. Now let tangent PT makes an angle theta with horizontal line PR. In right triangle TRP, tan theta will be TR upon PR, but tan theta is slope of the tangent to the curve dy by dx. Since points P and Q are very close to each other, tangent PT is approximately same as curve PQ. So therefore points Q and T will be one and the same, so that in place of TR we can write QR and write QR upon PR equals dy by dx. So that gives us QR equals dy by dx multiplied by PR. Now QR is MQ, that is yn plus 1, minus MR, which is yn, equals value of dy by dx at point P, that is at xn comma yn, multiplied by PR, which is this xn plus 1 minus xn. Now from this differential equation 1, we write dy by dx at xn comma yn as f of xn comma yn multiplied by xn plus 1 minus xn, which is this, and we have denoted it by h, so this will be h. So finally what we get is this yn plus 1 will be this yn plus this h times this f of xn comma yn. So this is known as Euler's numerical formula for solving differential equation dy by dx equals f of x comma y. Here we must note that Euler's method is more accurate when the step size h is very small, because then only this tangent PT will be approximately equal to the curve length PQ. If the step length h is not small enough, then we will not get better approximation by Euler's method. Hello friends, you are watching YouTube channel Number Collage. This channel features easy to understand concept videos on mathematics. In the first problem, we have to use Euler's method to find approximate value of y at x equals 1, where dy by dx equals 1 plus y square upon 1 plus x square, with value of y when x is 0, and we have to take the step size h equals 0.2. Since we have to find approximate value of y at x equals 1, and since the step size is 0.2, we will have to perform 5 steps to find the approximate value. We have, for Euler's method, yn plus 1 equals yn plus h times f of xn comma yn. We have to find values of y when n is 0, 1, 2, 3 and 4. So first, when n equals 0, this formula will become y1 equals y0 plus h f of x0 y0, that will be y0 which is 0 plus h which is 0.2, and f of x0 y0 will be this 1 plus 0 square upon 1 plus 0 square 0. So that gives us y1 equals 0.2. Next we have to find x1, which will be x0 plus h. x0 is 0 plus h is 0.2. So x1 will be 0.2. Now y2 will be y1 plus h times f of x1 y1, that will be, we have y1 equals 0.2 here plus h is 0.2 multiplied by f of x1 y1 will be 1 plus 0.2 square upon 1 plus 0.2 square. This will cancel with each other and we get y2 equals 0.2 plus 0.2, that is 0.4. Next we will find x2, that will be x1 plus h, but x1 is 0.2 plus h is 0.2, so x2 will be 0.4. Next y3 will be y2 plus h times f of x2 y2, so y2 is 0.4 plus h is 0.2, and f of x2 y2 will be 1 plus 0.4 square upon 1 plus 0.4 square, which cancels, and we get y3 equals 0.4 plus 0.2, that is 0.6. We have found y1 equals 0.2, y2 equals 0.4, y3 equals 0.6. Now x3 will be x2, which is 0.4 plus h, which is 0.2, that will be 0.6. So y4 will be y3, which is 0.6 plus h 0.2 times 1 plus y3 square, that is 0.6 square upon 1 plus x3 square, that is 0.6 square. This cancels out and we get y4 equals 0.6 plus 0.2, that is 0.8. x4 will be x3, which is 0.6 plus h 0.2, that will be 0.8. y5 will be y4, which is 0.8 plus h 0.2 multiplied by 1 plus y4 square, that is 0.8 square upon 1 plus 0.8 square. After cancelling these two terms, y5 will be 0.8 plus 0.2, that is 1, and next value of x5 will be x4, which is 0.8 plus h, which is 0.2, so that will be 1. So when x equals x5, y will be y5, therefore y equals 1 when x equals 1. These calculations can be conveniently carried out in a tabular form as follows. We will make columns of n, then xn, yn, then f of xn comma yn, which is given as 1 plus yn square upon 1 plus xn square, and finally we will write Euler's formula y n plus 1 equals yn plus h, which is 0.2 times f of xn comma yn. Now in the first row, when n is 0, xn is 0, yn is 0, f of xn yn will be 1, and so yn plus 1 will be 0.2. In the next row, we write n equals 1, xn is 0.2, yn is 0.2, and f of xn yn is 1 and yn plus 1 is 0.4. In the next row, n is 2, xn is 0.4, yn is 0.4, f of xn yn is 1 and yn plus 1 is 0.6. In the next row, n is 3, xn is 0.6, yn is 0.6, f of xn yn is 1 and yn plus 1 is 0.8. In the fourth row, n equals 4, xn is 0.8, yn is 0.8. f of xn yn is 1. So yn plus 1 will be 0.8 plus 0.2 multiplied by 1. So that will be 1. And finally, in the fifth row, we write n equals 5 when xn equals 1, which is 0.8 plus 0.2. Yn will also be 1. And this gives us approximate value of y equals 1 when x equals 1. In the next problem, we have to use Euler's method to find approximate value of y for x equals 1.4. It is given that y dash equals x root y and y of 1 equals 1, taking h equals 0.1. Here the step size is 0.1 and we have to find value of y at x equals 1.4. So we have to work from 1 in steps of 0.1 as 1.1, 1.2, 1.3 and finally 1.4. So we have to carry out 5 steps to find the correct approximation. Here we will find the approximation directly by tabular method. So we will make columns of n, then xn, then yn, then f of xn comma yn, which is according to this will be xn root yn and yn plus 1 equals yn plus h times, which is 0.1 f of xn comma yn. In the next row we will write n equals 0. So x0 will be 1 and y0 will be this 1 and x0 square root of y0 will be 1 into square root of 1, that will be 1, and y of 0 plus 1, that is y1, will be y0, which is 1 plus 0.1 multiplied by this x0 square root y0, that is 1. So y1 will be 1.1. In the next row, n will be 1, xn will be x1, which is this 1 plus h, that will be 1.1. y1 will be according to this 1.1, and in the next column it will be x1 square root of y1 will be 1.1 square root of 1.1, that by calculator will be 1.1537. Next y2, that will be y1, which is 1.1 plus h 0.1 multiplied by x1 square root of y1 1.1537, that will be 1.2154. In the next row n will be 2. x2 will be 1.1 plus 0.1. y2 is this 1.2154. Next x1 1.2 square root of y1, which is 1.2154. This by calculator will be 1.3229. Next y3 will be y2, which is 1.2154 plus h 0.1 multiplied by this 1.3229, which will be 1.3477 by calculator. In the next row, we write n equals 3. x3 1.2 plus 0.1, that is 1.3. y3 will be this 1.3477. Next 1.3 square root of 1.3477 by calculator will be 1.5092. y4 will be y3, which is 1.3477 plus 0.1 multiplied by this 1.5092, which will be 1.4986. In the next row, we write n equals 4. x4 will be 1.4. y4 will be this 1.4986. So finally what we get is y equals 1.4986 when this x is 1.4 as required here. In the next problem, we have to use Euler's method to solve dy by dx equals x plus y plus xy. It is given that value of y at x equals 0 is 1. We have to find the value of y at x equals 0.1, and we have to take step size h equals 0.025. Since the step size is 0.025 and we have to find value of y at x equals 0.1, we have to work through first x equals 0 to 0.025 to 0.05 to 0.075 to 0.1, which is this. So we have to take 5 steps to find the approximate value of y. We will solve this problem by tabular method. So we make the columns of n, then x of n, y of n, then f of xn comma yn, which according to this will be xn plus yn plus xn yn, and yn plus 1 will be yn plus h, which is 0.025 times f of xn comma yn. In the first row we write n equals 0, so x0 will be from this 0 and y0 will be from this 1. Next, xn is 0 plus yn is 1 plus xn yn will be 0 multiplied by 1, that will be 0. So f of xn yn will be 1. Yn plus 1, that is y0 plus 1, or y1 will be y0, which is 1, plus h, which is 0.025 multiplied by f of xn yn, which is 1, and that will be 1.025. In the next row we write n equals 1. x1 will be x0, which is 0, plus h, which is 0.025. So x1 will be 0.025. y1 will be this 1.025. f of xn yn will be x1, which is 0.025, plus y1, which is 1.025, plus product of 0.025 multiplied by 1.025, so that will be 1.0756. y2 will be y1, which is 1.025 plus 0.025 multiplied by this 1.0756, that will be 1.0518. In the next row we write n equals 2. x2 will be 0.025 plus 0.1, that will be 0.050. y2 will be this 1.0518. f of x2 y2 will be x2, which is 0.050, plus y2, which is 1.0518, plus x2 0.05 multiplied by y2 1.0518. This on calculator works out to be 1.1543. y3 will be y2, which is this 1.0518 plus 0.025 multiplied by this f of x2 y2, that is 1.1543. So that gives us y3 equals 1.0806 by calculator. In the next row we write n equals 3. x3 will be 0.050 plus 0.1, that will be 0.075. y3 will be this 1.0806. f of x3 y3 will be x3, which is this 0.075, plus y3, which is this 1.0806 plus 0.075 multiplied by 1.0806, that will be 1.2366 on calculator. Finally we will find y4, which will be y3 which is 1.0806 plus h which is 0.025 multiplied by f of x3 y3 which is this 1.2366. So that gives us y4 equals 1.1115 by calculator. In the next row we write n equals 4, so x4 will be x3 0.075 plus h which is 0.025, that will be 0.1, and y4 which we have already found here equals 1.1115. So that gives us our final answer. Value of y equals 1.1115 when x is 0.1 as required here. If you like this video, please share this to your classmates. Don't forget to subscribe this channel. See you in the next video. Until then, keep watching Number Collage. Thank you.